everyone! Today we're going to finish up our discussion of deductive logic. Last week we talked about categorical arguments and arguments like categorical syllogisms, things that were fundamentally about the relationship between classes or categories. Today we're going to talk about what's called propositional logic, or it also gets called sentential logic. This is another kind of deductive argument that is about the relationship between sentences or propositions. So that's what we'll be doing for today. Let's get started. Alright, so if you think back to the categorical syllogisms that we looked at, what made the arguments valid, what made the conclusions necessarily true, were particular ways of different classes to be related to one another, as we saw in many of the examples we looked at. In propositional logic, the same thing is going to be true, only it's going to have to do with the relationship that exists between different kinds of sentences. Now, propositional logic is an enormous field. We could spend the entire semester just on it, and indeed you could spend even more than a semester on it. You could go to more advanced classes that are all going to be about propositional logic. It's very commonly used in mathematical context, it's very commonly used in computer science context, and it's really commonly used in philosophy context. We're going to not go as deep into it, not as deep into it even as the logic appendix does. We're going to talk about at least some of the things that are in the appendix, but not everything. What we're going to focus on predominantly are what are called conditional arguments. So let's just introduce the idea of propositional logic, and then we'll spend the rest of the day focusing on the conditional arguments. So in the course of normal English, we actually combine sentences together in a pretty wide variety of different ways. I can say, I am going to the store and I need some milk. Right? I've got two different sentences. I'm going to the store and I need some milk. I combine those sentences with what's called the conjunction, the end, right? And that sentence is, that combo sentence is suggesting that both of the two things is true, right? I'm both going to go to the store, and it's also true that I need milk. Both of those sentences are individually true. There are also what are called disjunctions. I'm going to the store or I need some milk. That suggests that at least one of those two things is true, but maybe not both of them. Similarly, there are negations. I'm not going to go to the store, right? I'm saying that the sentence, I am going to the store, is false. That's not a true sentence. And then lastly, what are called conditionals. If I'm going to the store, then I need some milk. We use these conditional sentences all the time. They're really common. We especially use them to talk to computers, actually. And indeed, we use really all of these conjunctions in computer programming. Like I said, that's one of the key areas where you see propositional logic really get used a lot. What we're going to focus on today is just the conditional sentences themselves and the argument and some of the very simple kinds of arguments we can make just using conditional arguments. So students often find conditionals a little bit confusing. And so before we go into looking at conditional arguments, we're just going to look and see how conditional sentences are working just on their own term. Then we'll worry about how that kind of sentence gets used within arguments. So just as a sort of helpful terminology, we're going to first define the two different parts of a conditional sentence. So you've got the if part of a conditional sentence and the then part. We're going to say that the if part is called the antecedent. The then part is going to be called the consequent. So this is another example of something you just kind of need to memorize. We're going to use this vocabulary so that when we're talking about conditional sentences, we can distinguish those two parts. So the if part, antecedent, the then part, the consequent. There are actually lots of ways of writing things that have the same logical force in English as conditional statements that aren't just if-then sentences. You can do it with sort of whenevers, and we'll in the book goes through a couple of different examples. So just know that you're not always going to be looking at something that literally says if-then. You still might have something that has a slightly different look to it, but the logic behind it will still be the same. And so that's what we're going to be focusing on. Whenever we sort of standardize a sentence that features any kind of variant of this, we're going to standardize it in if-then form. Alright, so here's the best way I can recommend to start thinking about what conditionals are. Think of them as kind of a rule that you have to follow. So suppose, as an imaginative exercise, you find a strange machine. And you've never seen the machine before, you don't know exactly what it is the machine does. You're not even sure if it's working, actually. But the machine comes with a sheet of instructions, and it tells you what will happen if you do certain things with the machine. So, for example, let's say this machine's instruction guide says that if you put apples into the machine, out will come an apple pie. Helpful machine. Nice machine, like pies. but you don't even know if it works. How could you test it? Well, okay, first easy thing you can do to test it, right? Try sticking in apples into the machine. If a pie comes out, that's a very good hint that the machine is working. Indeed, that means the machine is working. If you stick in a bunch of apples and a pie doesn't come out, well, then you know the machine is not working. The rule sort of wasn't satisfied. But let's make it a little bit more complicated. What if you put in some other kind of fruit besides apples, say, something that the rule didn't tell you anything about? So let's say you put in a bunch of cherries. What should happen if the machine is working? Well, based on the instructions you have, it's actually not at all clear what should happen. Indeed, many different things could happen. Maybe the machine will take those cherries and make a pie, right? Maybe it's not only apples that it can turn into a pie, maybe it can turn cherries into a pie. If that happened, we wouldn't say that the instructions were wrong or that the rule was wrong. We would just say that it was incomplete, that there are other ways you could sort of get pies too besides putting in apples. But if you put in a bunch of cherries and it didn't spit out a pie, that also doesn't really say that anything's wrong with the machine or that there was anything wrong with the instructions you received about how to use the machine. Those instructions just don't say anything at all about what will happen if you put anything other than apples into the machine. And so, as a result, the only thing that's really relevant, the only thing that the machine really does, is according to the rules that you have available to you, it only tells you what happens very specifically. If the right input goes in, you'll get the right output. And that's it. So we're going to say that in if-then sentences, we sort of use this as sort of a metaphor to think about if-then sentences or conditional sentences. We're going to say that the if-then sentence is kind of a rule telling you what a machine does. The right input is the antecedent. And the output that you'll get if you put the right input in, we're going to call that the consequent. So in the sentence, if I go to the store, then I'll pick up some milk. That rule is a good rule if it is the case that every time I go to the store, I pick up some milk. If I don't go to the store, but pick up milk for some other reason, fine. That doesn't say the rule doesn't say anything at all about that the only way I'll get milk is if I go to the store. It just says that anytime I go to the store, I'll get milk. So the only thing that would actually make that a bad rule or sort of prove the if-then sentence false is if you went to the store and didn't get milk one time. Then you know that the machine is broken, so to speak, that the rule doesn't actually apply or the rule's not working the way that it says it does. That's the only way that an if-then sentence is ever false. Let's look at one more example. If I study, then I will do well in the exam. So this if-then sentence, again, if we think of it as sort of positing a rule of some sort, we know that if the antecedent sort of goes in, the consequence should come out. So if I study, I should do well in the exam. But the rule doesn't say anything like that the only way I'll do well in the exam is if I study. Maybe I could do well in the exam in some other way. Maybe I'll cheat. Don't cheat. But maybe I could cheat and do well in the exam. Or maybe I'm just, really got the material. I didn't really need to study for it this time. I can still do well for the exam. The rule doesn't say anything at all about what any of those other cases. The only case that the rule considers, antecedent goes in, then the consequent has to come out. If something else goes in, say I didn't study, who knows what result will come out? The rule just doesn't tell us. Maybe I'll do well, maybe I won't. Neither result will be a problem for the rule. Alright, now let's use this discussion that we've done about sort of what's logically going on with conditional sentences and apply it to some actual arguments that use sentences of that sort. We're going to look at 4 kinds of arguments today. 2 of those argument forms are going to be valid, 2 of them are going to be invalid. And all of them are going to share using a conditional sentence. So let's start with one that's pretty obviously valid based on what we've said so far. This is called modus ponens, or maybe a more helpful name for it, and feel free to use either, affirming the antecedent. When we're talking about argument in propositional logic, just like in categorical logic, we're going to use variables. So our variables here are P's and Q's. If any of you have ever heard the really old-timey saying, mind your P's and Q's, that's actually a reference to logic. Right? Get your sentences right. So, all right, using the just pure formal structure of the argument, here's an example of a modus ponens argument or an affirming the antecedent argument. If P, then Q. That's my first premise. Second premise, P. Conclusion, therefore Q. Or, concrete example, if I study for the exam, then I'll do well. I did study for the exam, therefore I'll do well. I think this one makes a great deal of sense. This one's probably not super surprising. Based on what we've said, the if-then sentence posits a rule. If you get the right input, you'll get the right output. All right, so that second line, the reason this is called affirming the antecedent, we're saying that the antecedent is indeed put in. Right? The antecedent is true. The antecedent is being affirmed. Right? So therefore, we should expect the consequent to come out if it's a valid argument. Because remember, validity means assume the premises are true, does the conclusion have to also be true? So if we assume it's a good rule and assume that the antecedent really is put in, the consequence is necessarily going to come out. So that one wasn't probably super surprising. Let's look at another argument form that maybe is a little bit more surprising, a little bit more unexpected though. This is called modus tollens, or again, maybe a more helpful descriptive name, denying the consequent. So here's the example in formal terms. If P, then Q is premise 1. It's not the case that Q, premise 2. Therefore, it's not the case that P, the conclusion. Think this is not the case that, right? You're just saying that the sentence Q is false. It's not true. Put it in terms of our machine. We don't put it in or get it out of our machine. And then concrete example, if I study for the exam, I'll do well in it. I did not do well in the exam. It's the second premise. Therefore, I must not have studied for the exam, or I didn't study for the exam. Again, this conclusion necessarily follows as a valid argument. We assume the premises are true, so we assume this is a good rule, and we assume that you really don't get the desired outcome. Well, if it's a good rule and you don't get the sort of expected outcome, the only other possibility is that you must not have put the right thing into the machine in the first place. Think about it in terms of the apples again, right? If all I know is I put something into the machine and it didn't give me a pie, I must not have put apples in. I don't know what was put in, but I know apples weren't. So it's necessarily true if we assume that the rule is a good rule and that we really didn't get the consequent as a result. A similar logic explains the two invalid forms that we're going to look at. So the first invalid form is called affirming the consequent. So here's this in formal terms. If P, then Q. Second premise, Q, the consequent, then P. Right? And why is this affirming the consequent? Because we're saying Q is true, we're affirming it. We're affirming that the consequence of the conditional sentence is true. Again, concrete example. If I study for the exam, then I'll do well. I did well in the exam. Therefore, I must have studied. This is actually an invalid form of argumentation because there are other ways that I could have done well in the exam besides studying. Like we said, maybe I cheated. Maybe I just really got the material and didn't need to study. For it to be a valid argument, we assume the premises are true, so we assume it's a good rule, but the rule doesn't imply that the only way the consequent will come about is if the antecedent is present. Other things besides the antecedent possibly could bring the consequent about. We don't know. The rule doesn't say either way. When we're dealing with validity, we need to be dealing with a necessarily true conclusion. There's other ways of doing well on an exam besides studying. So in this case, we do not have a valid argument on the basis of the premises. The same logic that we apply to the affirming of the consequent case also explains why this last case is invalid, denying the antecedent. So in formal terms, if P, then Q, not P, so it's not the case that the antecedent is true, is the second premise. That's why this is denying the antecedent. Therefore, it's not the case that Q is the case. This fails for the same reason that affirming the consequent failed. There's other ways of getting the consequent according to the rule besides just the antecedent. The antecedent's not necessarily, at least, the only way you could do well on an exam. There's other possible ways. So if you didn't study, that is not enough to ensure, based on the rule, that you will not do well on it. You could do well on it in other ways. Again, think about this sort of in terms of the machine example, right? You could stick in other things possibly besides apples to get a pie out of our machine. You could stick in cherries, maybe. You don't know, but you don't know that you can't do it either. And so since there's that uncertainty, we don't have a necessarily true conclusion, we don't have a valid argument. All right, that's all we're going to do with propositional logic in this class. There's a lot more to do with it. If you take the 200 or 300 level logic classes here at CSU, you'll get to do a lot more propositional logic, spend a lot more time, go in a lot more depth into it. Indeed, there's many other argument forms that use conditional sentences even, just besides these four that we've looked at. But these are four at least helpful ones that help you to sort of think about conditionals in general. If if you can really understand and really explain why all the valid arguments are valid and the invalid ones are invalid, you'll have a very solid grasp of these conditional sentences. In class, we'll work on that a little bit. We'll work on identifying these different argument forms, maybe talk a little bit more about conditional sentences, what makes them valid and invalid. My guess is we'll also want to do a little bit more review and discussion of some of the categorical syllogisms from last class week as well. So that's what we'll do in the class session. All right, talk to you all later. Bye.